right, so this is a yes-no data sufficiency question, and the question is the absolute value of x minus y greater than the absolute value of x minus the absolute value of y? And a lot of times it can be difficult to see what they're actually saying here without testing numbers. And the best approach for yes-no questions is to basically try to break the statement and show that it's insufficient. And only if we find that we cannot break it do we accept that it is insufficient. So statement one, y is less than x. Does this mean that this top part has to be true? Is it always consistently the same yes or no answer, basically? Well, following y is less than x, I'm going to say x is 5, y is 4. And I just chose these numbers kind of randomly, but they're simple numbers to work with, so it made sense to use them. The absolute value of x minus y is 1, and the absolute value of x minus the absolute value of y is also 1. So that would answer this question, no. This side is not greater than this side because they're actually equal. So when you're evaluating yes-no questions and you get a situation like this, it's important to know that that would be a no answer to the original question. Now, can I get a yes answer? Because if I can get a yes answer, then I've proven that statement one is insufficient. So I'm going to keep the situation following the rule where y is less than x. I'm going to make x -4, and I'm going to make y -5. And the reason I did this is I wanted to see what would happen if I started using different sorts of numbers, like negative numbers. And what I find is that the absolute value of x minus y is still 1, but the absolute value of x minus the absolute value of y is -1. And so this side is larger than this side now, and that would answer the question yes. So I've proven that statement one is insufficient because I've shown that I can get both a yes and a no answer. Let's look at statement two on its own. X times y is less than 0. Well, that means either a positive times a negative or a negative times a positive. So let's mess around with it and see what we get. If I make x +5 and y -4, then I find that the absolute value of x minus y is 9, and the absolute value of x minus the absolute value of y is 1. And in this situation, this side is greater than this side. Now, if we flip it, because it didn't say which of the two numbers was positive and which was negative, I find that I still get an answer where this side is larger than this side. And no matter what we do messing around with these numbers, if I make it -10 and +1, for example, trying to make this really negative and this really positive to see if it creates a weird situation, what I'll find is that the difference between them is always greater than it would be if they were both positive, because +10 minus 1 is closer than -10 to +1, because we have to cross across 0. We have to go all the way from the absolute value of this to 0 and the absolute value of this to 0 for a combined distance. And so if one's negative and one's positive, then this solution here is definitely going to be bigger than the difference if they were both positive, because then the absolute values are closer to each other. And that's the thought process that they're getting into. But I think the main point is test numbers. If you test 3 different situations in a row and you always get the same answer, which in this situation was yes, this side is greater than this side given statement 2, then you know that your answer is sufficient, which means that answer choice B is the correct answer.